All right, we're going to do a quick review of inverse trig functions that we talked about in pre-calc. So inverse trig functions is going to be one of our inverse trig functions. Typically, that's sine of negative to the negative 1 is our notation for inverse sine. We also sometimes will use the notation arc sine. These mean the same thing. And what an inverse trig function is going to do, it is going to find an angle for a given ratio. And that's one of our given trig ratios. So if we remember our trig ratios, those are our SOHCAHTOA and things like that. So remembering our SOHCAHTOA can help when we're doing these things because we will set up right triangles and do a lot of our basic trig to find these values. So if you recall from pre-calc when we talked about just finding values, the inverse sine of a half, what that really means is we're trying to find some angle, and that angle, let's call it theta, that angle has a sine of 1/2. So if I look on my unit circle, I'm looking where sine is 1/2. Remember, sine is the y-coordinate. It is right here, and there's also one right here. Now, we always pick one of them. We never pick both of them. So the ones we pick for sine are going to be in quadrants 1 or 4. Cosine is in quadrants 1 and 2. And tangent is also in quadrants 1 and 4. So we will pick this 1/2 here. So that angle is pi over 6. So the inverse sine of 1/2 is pi over 6 because the sine of pi over 6 is 1/2. That's its inverse. Now for this one, the cosine of negative radical 3 over 2, we're trying to find some angle where the cosine of this mystery angle is negative radical 3 over 2. So if I look here, now cosine on the unit circle is the x value. So I'm looking for negative radical 3 over 2. That's right here, and it's right here. But of course, I want to look in quadrants 1 or 2, so I'm looking for this angle here. So the inverse cosine of negative radical 3 over 2 is 5 pi over 6. That is my angle. So inverse trig functions are taking an input of a ratio and giving you an angular output. Now, we won't be doing a lot of values like this, but what we will be doing is we'll be using a lot of the definition of inverse trig functions to verify our derivatives and things like that for our last functions that we'll find the derivative of, which are these inverse trig functions. So these are very, very typical problems we will have where it says given the inverse cosine of x equal y, this is some kind of function, what is the sine of y? So how this works is when you have an inverse function, you can actually write this by switching x and y. So I can actually write this, cosine inverse of x is the same as cosine of y equals x. Now if you remember for inverse cosine, it gives us an answer of an angle. So y in this case is an angle. So this y is an angle. So when you say cosine of y equals x, this is the cosine of some angle equal x. When you have a cosine or a trig ratio, you can set up a triangle. Now if you remember cosine from SOHCAHTOA is adjacent over hypotenuse. So in this one, the adjacent is x, and the hypotenuse, it doesn't have one, so we'll just say it's 1. So in this right triangle, if I put y here, this is my opposite side. This is my adjacent, and this is my hypotenuse. So the adjacent side is x, the hypotenuse is 1. Now to find the missing side here, we'll just use Pythagorean Theorem. We'll call this a just for now. So we know a squared plus x squared equals 1 squared. So a squared equals 1 minus x squared. So a equals the square root of 1 minus x squared. So we always want to express our triangle in at most one variable. So now I can do everything I need with this triangle. So this triangle says what's the sine of y? Well, the sine of y, remember sine is opposite over hypotenuse. So the sine of y is going to be the opposite over the hypotenuse, which is just 1 minus x squared. So the sine of y, given the inverse cosine of x is y, is simply radical 1 minus x squared. So setting up this triangle will be really, really important, and it's how we will actually prove these derivatives. So let's look at one more. This one I have the arctan, and we're going to find sine y. So arctan or inverse tan, remember, if I switch that around because they are inverse functions, I could write this as 5x equals regular tangent of y. And again, this is an angle. So in tangent is TOA, remember? We have SOHCAHTOA. So tangent is TOA. So that would mean 5x is opposite, and the adjacent, we don't have one, so we'll just say it's 1. So in this triangle, with this angle y, and I'm just going to put it in this one randomly, the opposite is 5x, the adjacent is 1, and now we have to find this other side. We'll call it h. So h squared equals 5x squared, which is 25x squared, 5x times 5x, plus 1 squared, which is 1. So the hypotenuse is 25, square root of 25x squared plus 1. Now once you have this is relatively straightforward, because now we're just finding sine of y. And remember, this is opposite, this is adjacent, this is hypotenuse. So sine is opposite over hypotenuse. So the sine of y is going to be 5x over the hypotenuse, which is square root of 25x squared plus 1. So the sine of y, based on this simple fact that the arctan of 5x is equal to y, is this expression here. So we'll practice this a lot more when we do some of these derivatives, but practice a couple of these today. And hopefully we remember a lot of this stuff, but I know it is kind of a difficult topic.